And now it's loading the scene. I'm not sure if you can hear how bad the fans of this laptop are now spooling up. I guess it will sooner or later die of heat. And here we are. Okay, see you inside. So, here we are. Or at least I am. I need to have the handles in my reach. Okay. Now I'm turning them on. Got to arrange the cable a little bit. And when I move them around, yay, here's my controller. Chat, by the way, if you're chatting right now, I can't see. Okay? I will come back to you later. I hope you don't mind. Okay, I don't see my second controller. Time to turn it off again. And turning it on. Hey, here we are. Okay, now I could walk through here, or I can just stay seated and move around here. The controls work a little differently than in other applications. The first thing we can do is we can use our pointing finger to grab the model and pull it towards us. Yeah, it's quite a slow movement, but that works. But when we can grab it, we can also like turn it around in this direction or in that direction. So yeah, here's nothing. That's just the end of the wind tunnel. Okay, but we could also like tilt it upwards and downwards. And the funny thing is, when I look up and tilt it up as well, I don't move because it's relative movement. Okay, that's nice for now. But let's get things going. Here is the first mode. I can see on my controller it says push, pull. If I push myself away from the model, and if I pull myself closer to the model. I don't like this way. I like my controls to be inverted. And now we have that little plane up here. Yeah, maybe you can see it. Which indicates I'm in fly-through mode, so I can fly in the direction that my controller points to. Yay! Okay, cool. Yeah, let's turn around. I could also like rotate, but then I'm not straight in front of the camera, obviously. So here we are. We have two cars here by our sides. And there is a little difference between them. Maybe, chat, you can already guess what this is all about. But on the left cars, the passengers are bright red on the chest. And on the right side, they are all pale blue. Furthermore, on the left side, these guys have dark blue shoulders. Whereas the guys on the right side, yeah, they have palish blue color. And this is just surface pressure, which is visualized in this simulation. Yeah, and why? Of course, because of these tiny little windshields that we can see. We can go further and inspect it a little bit. Yeah. Here we can see they have a tiny red spot on their forehead, which means slight positive pressure. As this was my first scene, you can hardly see the legend down here, the color bar. Yeah, I'm sorry for that. We'll do better next time. So, here you can see like the pressure on the people in the car. Let's take a look at the other guys. Yeah, they are bright red on the chest and even dark blue on their shoulders. And at that point, we used it for marketing purposes to showcase, hey, that's what CFD is for. You can distinguish early in production without building a prototype how cars will behave in the air on the street. But yeah, that's enough pressure, looking at pressure. What we can also do is we can take any vector field and integrate along it, like that. Woohoo! We are making bubbles. It's maybe a little bit hard to see because those bubbles are so tiny. I'm just making them a little bit bigger and maybe a little bit slower. Okay? Yeah. And with these bubbles, we can just visualize the airflow. Here we are just hitting the we're actually going under the hood. And just here we are hitting a spot where the flow travels below. And when I was at a fair, I told people who never came into contact with CFD, well, yes, see these red bubbles below? Red means fast. Blue means slow. And yeah, let's see. Yellow is somewhere in the middle. I guess yellow means something like 100 kilometers per hour. Whenever these bubbles turn blue, this is an indicator something is blocking the stream. Yeah? And when something is blocking the stream, that is air drag, obviously. We found some air resistance, basically. But the other effect is also like, see these bubbles turning red under this obviously not very aerodynamic car? Yeah, that's downforce, basically. It's speeding up particles, or airflow, better to say, below the car. So turning them a little bit slower so we can see better, maybe. Okay. Everything still running fine? Skoloppos. Yes, it's nice. It's sheesh. You are right. You are right. Okay. Where are my bubbles? My bubbles are there. Okay. You can also use these bubbles to find areas where you have like recirculation, like this. And then also visualize how the air is not even moving behind the car. Okay. Nice. Correcting my view a little bit. So let's get over to the other car. Here you can also see that when I spawn the flow just right here, it directly hits the driver in the face. Yeah, and that's surface pressure. That's resulting in the red spots. Here at that point, you can hardly, at that car, you can hardly fire bubbles at his head. Because, yeah, they are just deflected by that windshield. Yeah, there we hardly manage, nearly manage. But it's nearly impossible. And you can also like visualize what happens at aerodynamically critical areas like the slat of the tire. Yeah. Okay. That's it for bubbles. One overview of the scene. Yeah, that's the scene from above. The scene as seen from above. Okay, let's delete these bubbles by just taking the other controller. Here it says flow. Come on. And at the other side it says plus minus. So plus setting this cone, minus erasing it. So let's delete the nearest cones one by one. And we are bubble free again. Woohoo! No, there's still one. I forgot the vertex. the vortices. Now we should be bubble free. Sooner or later, there's some, I don't know by which logic they actually despawn, but they should in some method. Okay, let's get to the next controller, because up to now I have only used my right hand, apart from like setting these cones with plus and minus. Okay, the left controller can do something like scale. I'm gonna scale very small, not very, very big now, and which results in the bubbles turning gigantic. And my movements turning fast. See? I'm traveling at the speed of light, basically. Whoops! I hit the keyboard. Something happened? No, nothing happened. Okay. So, let's scale more like that. And we are very, 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 very slow. See? That's like, we are not even moving then. So what we could do is like scaling up and walking through the battery here. If we wanted to. We could walk through the battery because we fit in. Scaling a bit out here. Scaling out, getting faster. Here we are back again. But that's not all we can do. We can also, with the left hand, visualize plane sections in pre-computed scale with pre-computed scalars. So, for example, on this here, I have, I guess it's turbulent kinetic energy, which I have visualized here. Yes. And you can, I know that's just a auxiliary quantity, just some scalar from the RANS simulation, and you can visualize it for both of them, and you can see, that's nice. Take a look at this, and you can also take that very scalar and turn it into an isosurface, controlling the amount with your hand. The only thing lacking here at that point is a legend. But still you can see how you can slide through these same amounts of turbulent kinetic energy. Works with the other car as well. I can also like set it now at that and add a second one if I wanted to. Here we go, 2 layers. Removing them. Here we go. Yes. Okay. In my opinion, in your opinion, how companies can benefit from these VR applications? Well, I know that these applications are in use for several companies. I will not name them here, but for example, you can show your one-of-a-kind product to potential customers. You have a business where it really comes down to energy, to drag reduction or whatsoever, and you can show to your customer, hey, this is a simulation of our product, and it will behave like this and that, so you can use it as an additional tool for to help in sales. The other point is you can also use it as a tool to make communication between different knowledge levels easier. For example, you are talking to your manager and you are the CFD expert and you want to show something. For example, how the backflow behind the windscreen really is. Yeah? Then you take him or her into the simulation, take them with you, both have headsets on, you collaboratively join, and you say, hey, look at this. See the backflow? Right there. Okay? And then you can say, yeah, but I have found some interesting geometries that create downforce. And the manager is like, downforce? With this car? Never, ever, ever, ever. And you say like, come on, see this? There is some accelerated flow below. And then you can also say like, okay, the windshield is big enough, you will never hit the head, and so and so and so and so. So communicating between different knowledge levels is fairly easy with such a tool. Okay? What are the computer specs I'm running this on? Well, the computer specs I can directly show you. Control, Shift, and Escape. So this is a gaming laptop, and it has some 12th gen Intel, which is not used at all. But the heavy load is currently on an NVIDIA GeForce RTX 3080 Ti, which is, yeah, at 46% usage and really melting inside that laptop, I suppose. Poor graphics card. You can't, by the way, Calex 2018, thank you for chatting for the very first time. I hope you liked my answer. You can hand mesh. No, it's not, it's limited currently what you can do productively inside this virtual reality setting. It's more like an extra viewer at that state. Some complex geometries can be very challenging to fix prism layers on, but you can use it to inspect the mesh if you want to. Yeah, this is possible, and I'm not claiming that virtual reality as this application will ever replace mouse, keyboard, and screen. Yeah, but the mouse did never replace the keyboard. Yeah, it was another tool, another human machine interface that we use every day. And maybe one day, I mean, this once upon a time was $600. Yeah, so this is like little value when you compare it to engineering cost, right? Okay. So let's go for another simulation, shall we?